How long does it take the Earth to make one complete rotation around its axis? 24 hours or 1 day? If we look at the same image of the globe, but from the top, looking down the axis from the North Pole, we see the Earth is rotating counterclockwise around the North Pole. If we look more carefully at this axis of rotation, we see that it is tilted relative to Earth's orbit around the Sun. Instead of being perpendicular, it's tilted 23.5 degrees. How long does it take the Earth to make one complete orbit around the Sun? 365 days, or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not in the center of the ellipse, but one of the focal points. Bottom line, the Earth is a little closer to the Sun every January and a little further away every July. Does that cause us to have seasons? Let's think about it. We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that our warmest season in the Northern Hemisphere? No. So the seasons must result from something entirely different. Let's return to the tilted axis of the Earth. As the Earth orbits the Sun, it goes through 365 daily rotations, while the axis maintains its tilt. On the June 22nd solstice, the tilt causes the North Pole to face towards the Sun, while the South Pole faces away. When the Earth's orbit takes it all the way around to the December 22nd solstice, the North Pole is now tilted away from the Sun and the South Pole towards. This tilt explains why the North Pole experiences winter in January, while the South Pole is experiencing the opposite season, summer. The North Pole is facing away from the Sun and gets less overall sunlight. The South Pole is facing towards the Sun and gets more. To understand this more fully, let's look more closely at how the Sun's rays hit the Earth. First, notice that halfway in between July and January, during the September 23rd equinox, the tilt causes neither pole to face away or towards the Sun. As the Earth rotates every 24 hours, each area of Earth's surface will receive 12 hours in view of the Sun and 12 hours out of sight of the Sun. 12 hours of day, 12 hours of night. Equal lengths of day and night is why this time is called an equinox. As the Sun's rays hit the surface, they are strongest at the equator, directly in the middle, where they hit at a 90-degree angle. As Earth moves towards the December